everyone, welcome to the new video. So today we will discuss some Linux important concepts and we'll discuss it in a form of question and answers. Why? Because recently I've been realizing that when we say that we are working as a DevOps engineer and we know Linux, we should also know about these things which we don't uh, focus on. So without further ado, let's go. So when you press the power button, what actually happens in the backend to turn on the system? So we miss all these small details, but today we'll discuss about it because we should know about it that when we press the power button on computer or server, a complete chain of hardware and software events start in milliseconds. From motherboard initialization to loading the operating system, every step is important, and then we see finally our system is up and everything happens in milliseconds. So the complete boot sequence is, first of all, when we start power supply, it checks the voltage stability and all that thing. So it gets a good signal to get to the motherboard to have a power good go ahead. Then after that, then our CPU gets activated. It wakes up and look for firmware instruction, like it starts executing code stored in BIOS, basic input output system, like in old system, and UEFI in modern system. Then it checks for step 3 post power on self test. The firmware checks hardware components like RAM, CPU, keyboard, disk, drive, GPU, and if anything fails here, we hear sometimes the beep sound or a hardware error message. Okay, when some check fails here, then we see the error like this. Now this is a sequence that first of all CPU and that BIOS initialization is there, master boot record, bootloader, early, full kernel, and all this. Then after that, we haven't discussed more step after 3. Then step 4 is bootloader starts. Like after hardware verification is done, basic like BIOS or UEFI search for a bootable disk. It loads the bootloader, which loads the kernel into the memory. So it loads grub in Linux and Windows boot manager in Windows. Then the kernel is initialized, okay, which helps in the communication between the user and the system. So it detects hardware, loads driver, mounts root file system, start memory management, start process scheduling. Then this is a boot process explained, power on, then BIOS, UEFI, detect devices, choose a boot device, then accordingly it will load if it's a Linux or a Windows. Then it executes first process, which is systemd. So that also we'll discuss. It run target file, it starts all the services using systemd, and now the user sees the system up. So step 6 is PID 1 starts. Once a kernel is ready, it launches a first user space process. Usually this is systemd, and PID 1 becomes a parent of all the system process. So PID 1 is the first process and it is usually systemd. It starts all the services. Systemd, it will start networking, SSH, Docker, databases, logging service, GUI, desktop environment. And finally we see the login screen appear and system becomes usable. So this is a flow chart that we can first power button, then BIOS and hardware check, then post hardware check, then bootloader, kernel, systemd, services, login screen. Now what is systemd? As we have heard about this systemd before, like in this, we'll learn about it more. That systemd is a service manager and initialization system used in most modern Linux distribution, and it is responsible for starting services, managing background process, handling boot sequence, and monitoring system services. So without systemd, Linux server would not start automatically. Boot would be difficult to manage. So all the services, we use systemctl status, and to start also we so system boot process is defined like multi-user task, default task, then multi-user task, basic task, this target, then sys init target. This is also target files are there. Okay, multi-user target, basic target, rescue target. So basically systemctl, all these we are able to start the services using these commands, and this happens because of systemd. So key features are parallel service startup, faster boot time, service monitoring, automatic restart, logging through journal. Then comes what is PID1. This also we heard, and we'll discuss it briefly. PID means process ID, and every process in Linux have a unique number, but PID1 is the first process that gets started, and it is usually systemd. So what PID1 does, it starts all the other services, becomes parent of orphan process, and keeps system alive. And if PID1 crashes, then entire system becomes unstable, system may panic or freeze. So command to check PID1 is ps-v1. So it will give that we have systemd as PID1 if you want to check. Another thing is, if any service is already running on the same port number, what will you do to run another service if suppose we have given the same port number to that service also? So what will be our solution? So it's like only one service can listen on the same port plus protocol combination. So if Nginx is running on port 80 and we have another app, but we cannot run that app on same port. So it is because the address is already in use. So check which what are first step to check that which process is using which port. The commands are nets, they are TULNP, and we can grab specific port number if you want to check first that what all ports are already in use. Using SS also, using ls off also, list of all the port numbers. After that, because if we are using the same port number which is already in use, our service will not be up and running. So solutions are either we change the port number, we run the another service in another service with another port number, or option B is you stop the existing service and you kill the process ID, stop the service and then run. Or option C, use reverse proxy, they route traffic to multiple backend. So if sometimes whatever URL it will hit, accordingly it will be directed to different app or services. So yeah, these were the few major concepts that came into my mind and we should know about it. I'm thinking to take up more of these kind of questions because to understand more about Linux deeply. That's all for today's video. I hope it's helpful. Please let me know views in the comment section. Till then, take care. Bye.